Great. So Pietro and I are going to do the security session. We're going to split this up into the part that's the Google part and the part that's the Zebra part, because Google and Zebra work together to deliver security to Zebra devices. So the first thing that I want to talk to is all the scary headlines that you see constantly in the trade press. And then we're going to actually look at the real numbers for each of these vulnerabilities. So you can definitely be forgiven for thinking that that Android is insecure if you were to just do nothing but read the headlines, right? So you see scary headlines like this, the fake ID bug, the master key vulnerability, there we go. Last year, we had stage fright, which did one thing that was really positive in the Android ecosystem. It got the device manufacturers and the carriers focused on a more frequent update cadence. Certainly, one of the interesting things that we've seen as a result of all this is that, there we go. Oh, and then also kernel level vulnerabilities. And for those of you that have been paying attention, we've done some things in Android Oreo to make those kernel level vulnerabilities even more difficult to exploit. But with all these different vulnerabilities that are out there, we can actually see what's actually happening in the field. How many devices are actually being exploited? We have, not only can we look at the applications that are being, the applications are actually showing up on devices and tracking which applications have vulnerabilities that are potentially harmful to those end users in those devices. But we can also see exactly what's going on in terms of how many devices are doing things where we've got particular triggers because of SE Linux and other security measures that we've taken. We can actually see when certain sensitive operations happen. We can see certain patterns. And so, you know, let's take that master key vulnerability. That was the worst one to ever hit the Android ecosystem. At one point there, or at least cumulatively, we've seen approximately 1,200 APKs that try to take advantage of this vulnerability. And at its peak, when we saw the vulnerability in the wild, we saw a maximum of 8 devices per million being exploited with this vulnerability. So if you consider some of the worst exploits that you've ever seen on Windows, for instance, you know, this is an order of magnitude less problematic than what you're already used to in Windows today. And none of those exploitations happened before the public release of the bug. In fact, the next most serious vulnerability was the fake ID vulnerability. There were 258 APKs that were found to be exploiting this. And at its peak, we had 1 device per million that was compromised. Stage fright, even though it got a tremendous amount of press, at this point in time, we still have yet to find any evidence, and we've been looking everywhere for evidence that, apart from a proof of concept that we saw a researcher do, and that proof of concept required you to sit for a long time on a particular web page that was acting strangely. It's just simply not been exploited. And you know, the good news for all of this is that because of all the different things that we've done with the Android architecture, the diversity of that Android ecosystem, the things that we're doing with Play and Play Protect, right now, if you look at across all of Android what the potentially harmful application rates are that we see on devices, it's been consistently low for many, many years. And we need to update this. It's you know, continuing on this trend. There's nothing that's really changed since this slide. But what you're seeing across the entire Android population is that you're looking at a 0.69.7% rate of devices that have potentially harmful applications. Now, if you go further and you break that out by which devices are only using Play for application distribution, you'll notice that that number goes down to 0.05% of that device population has any kind of potentially harmful applications detected on it. And in fact, if you then look at who has potentially harmful applications that is allowing for unknown sources, using other app stores and distribution channels, you see about 1% of those devices will have a potentially harmful application. So the single most important thing you can do to protect yourself is by only using Play for your application and distribution, and by not allowing unknown sources. We've also got an API that allows you or your EMM to validate that the Play Protect is there and that the state of Play Protect is that no harmful applications have been deployed. So you can even get a list of potentially harmful applications. So these are APIs that are all available for that. But more important, we have an API that is available to any app developer. You can use this in your own applications. Your EMM can use this. Anyone can call, you know, up to a certain number of times per hour this safety net attestation. And what we do with that attestation is we send a test onto that device that can only be answered by the certified version of the firmware. We get a copy of every certified Android device firmware as part of the process of certifying each device. So if you're on a legitimate certified Android device, this API, you can call this API and you can know that the device hasn't been modified, it hasn't been rooted, that you're running on the version of firmware that was designed for that device. And any attempts to root the device are going to cause that attestation to fail. Now, if you were to just ask the device, are you rooted? Obviously, a rooted device can just say, yes, I'm fine, don't worry about me, right? So that's not enough. You've got to be able to do it in a way that a compromised device has no chance of being able to pass this attestation. And so the kinds of tests that we do is continuously changing. It's based on information that we have in the cloud, and if you look at the communities that have tried to get around it, you'll find that all of them have given up now on being able to bypass this attestation. It's very important for any application and any use of an Android device where you want to make sure that the device hasn't been rooted, that it hasn't been compromised, that you're on the version of the OS that was intended for that device, right? Who's the largest user of this attestation API? It's not what you might think. It's not a bank. It's not an enterprise. This is a picture of a bunch of people using this app in Japan. We service about 3,000 attestation requests per second for this app. Pokemon Go. Now, why is it so critical that Pokemon Go not be running on a rooted device? Well, their whole business model evaporates if you can go in, root the device, set the GPS to go pick up all the interesting Pokemon. It's gone. It's ruined. It's ruined the experience for the other players. The monetization model they have depends on this. So if this stops working, you know, they're in trouble. This has been one of the key factors for them to have a successful gaming experience, because this allows for all the things that they want to do that are unique about this game, without having to worry about somebody coming in and bypassing the functionality on the device that is tied to location. Yeah, do you want to talk to this one?
Yeah, it's about even the use case that we have. That in a lot of cases, the potential harmful application to be able to use some of the vulnerabilities that are discovered on Android needs to be installed on the device. So it's very important that, like in our market, if you can lock down the device with a white list of application, it's a very good idea to use something like a device policy controller, or having working the COSU on a COSU device, so that no potential harmful application can be installed. In this case, most of the vulnerabilities, more than 90% of the vulnerabilities discovered for Android, cannot be exploited. So this is a key point. So of all the information you see about Android, the work that Google is doing is wonderful, but keep in mind that in most of the cases, you need to install an application that uses these vulnerabilities to be able to exploit it. Otherwise, you are fairly secure with what you already have.
Yeah, being able to control the path for application distribution is critical. If there's no way for a compromised APK to get on the device, the ability for that device to be compromised is reduced substantially, right? And so let me talk a little bit about what Google's role is overall with ecosystem security. Google doesn't produce the firmware on Android devices. So Android isn't like Windows. We don't have a single system image that all devices use. We produce the source code. We distribute that source code to device manufacturers and chipset vendors. Those chipset vendors then take that set of Android source and they add their drivers and they add the other customizations that they need to do to be able to support that particular chipset. And they provide that to device manufacturers like Zebra and others. And from that point, Zebra makes further modifications. They add drivers for other chipsets and peripherals that are part of the device. They provide a build for their particular firmware. At this point, what we've done is we've provided the beginnings of that process, and we continue to provide patches and updates for the source code, but you can see that there are several downstream consumers of that source code that need to further consume those patches, need to distribute those, right? This is where Android's a little bit different than what most people realize. And of course, application developers do a similar thing with their applications. They control the applications, and then Google handles the distribution of those applications through Play, right? And then each of these is going through different sources to get to the end users. Now, Google Play services, the Google applications, especially the ones that are preloaded on the device, Google's responsible for keeping those up to date and secure. So when you look at what is Google doing to ensure the security of Android ecosystem, right? The first and most important thing that we do is build a robust platform that every device manufacturer can build on safely and securely. And I think what a lot of people overlook is how much is already built in to the platform itself. And it's easy to forget that in the Windows world, any application can access essentially any part of memory. This is not true in Android. In fact, not only is it difficult for one application to access memory from another application, these applications themselves are running as separate Linux processes. So in a Windows world, most of your applications are running under a single user process. You might have a few things that are running a system that have higher privileges, right? In Android, each individual application is running as its own Linux process. It's having to go through the SE Linux rule sets, and access between one application to another application is severely limited. Access between the Android applications themselves and the system is very limited. Even the system processes are broken out. And what you'll see if you've been following the architecture improvements that we just released in Oreo, we've taken many of these processes and further broken them down into compartmentalized, segmented parts of, rendering, for instance, being in a separate process from other processing, right? And so when you couple that with the capabilities that you get in Trust Zone, which is a separate hardware execution environment that's on that chip, it's a trusted execution environment that is completely not reachable from the general computing portion of that chipset. We've got all this process isolation, we've got hardware isolation, we've got a root of trust that's coming all the way back from the bootstrapping process in the first place. When that device boots up, there's a validation that happens. You'll see very noticeable warnings if you change the firmware that your typical end user won't be able to make those changes without seeing every time the device boots up that it's running something that's not certified, that's potentially harmful, right? Data encryption. Every Android device since Marshmallow has had volume level encryption at a minimum. If it's newer than, if the device was first introduced in Nougat or later, then we're able to make use of a new file-based encryption. That allows you to reboot without having to put your credential in. And what happens is that reboot happens, the system is able to run, but none of your individual personal apps are going to be able to run except for things like alarms that are using special APIs to get unencrypted access to data. As soon as you sign in for the first time, those other apps are unlocked. And when you use this allows you to have complete integrity for the encrypted file system. If you've got an encrypted file system with the older versions of Android, and you check the box that says, allow boot without asking for a credential. Well, we have to store that credential somewhere for the boot process. You've just lost a great deal of security. What you want to do is be able to boot first and then not complete the entire process until you've provided your lock screen credential. A number of things that we've done to make it much more difficult to exploit Android. We have address space randomization. So the addressing that gets assigned to particular memory for a given application will be randomized enough that it's very difficult to perform a Stack Overflow attack. We have a number of different checks that can be turned on by the app developer with their source to help avoid common problems. The web view is now being updated as a separate application so that as bugs and vulnerabilities are discovered in the web portion of the device, that those can be fixed without having to get a full firmware update. The media server, which was the subject of the stage fright vulnerability, has been hardened and separated and brought into component pieces that are locked down in their respective areas. And then on the management side, I spoke earlier about device owner and profile owner, these new management models, and the ability to control policies at a much finer grain. There's these new APIs, there's the integration with the VPN service. You can even do per application VPN. If you're using a profile owner, for instance, you can do VPN. In fact, if you set up a VPN inside the profile, it only applies to the enterprise apps there in the profile. And then nobody is spending more time, more energy, and paying out rewards to independent security researchers to help ensure that Android is absolutely as secure as possible. And we've paid out over $1 million in the last 12 months to security researchers that have discovered vulnerabilities that we then patch and provide to the rest of the ecosystem. So I've spoken about some of these safety net services. I've talked a little bit about what we do to validate that individual applications are not potentially harmful, and the sensor network that we have to detect and find these. We've got certainly in Device Manager itself the capabilities for remotely locating and wiping device. If you're using an enterprise mobility management solution, of course, you can use these as well. And then APIs for developers, for EMMs, for in-house applications. There's a complete set of solutions that take care of these things. And so on the lower left is what's happening on the device. And you've got Android itself and all the protections that are built into Android. You've got the Verify Apps portion that is helping to identify apps that we haven't seen before, make sure those are sent up for analysis. We're taking we've got the attestation API itself that allows for individual applications to validate that the OS hasn't been modified. We've had the safe browsing APIs that are actually available for any app developer, not just Chrome, but Chrome uses those. We've got the capabilities Device Manager of Smart Lock. Smart Lock allows you to set policies so that you can have a stronger lock screen credential, but ask for it less often. So you can do detection, say, with a Bluetooth device, and when that Bluetooth device is within range, then you won't be asked as frequently for your lock screen credential because you know that it's close to the person that the device belongs to. Similarly, you can, there's an on-body detection that will use a number of heuristics to determine that the device hasn't been sitting anywhere for an extended period of time. So those can reduce the number of times that the user is asked to unlock, which allows you to have a credential that's a little bit stronger because convenience isn't nearly as much of a factor now. They've got access to their device when they need it, and then they present their lock screen credentials at least once a day, but certainly less frequently. We've also got inside Play itself. We're doing a tremendous amount of checks. If you've ever submitted an application to Play, and no, I think it's just the screen. It just loves to soak that light in, yes. So what we're doing on Play has been a cumulative effort, and so you'll find if you use an older version of OpenSSL, for instance, we'll flag that and won't let you publish that app until you've used a version that's not vulnerable. If we see an SDK in there that has known issues, malware associated with it, right, we'll block that. All of this works together along with other Google services to ensure that there's a complete wrapper of protection around those Android devices. And this is only true for GMS devices, that you get this complete solution. We're protecting so many devices out there. We're doing a billion device scans every day, 50 billion apps. And we're working very closely with the ecosystem, with the application developers, for the apps themselves, with the device makers like Zebra, for their firmware, their updates, with the carriers to help ensure that their approval and distribution process for firmware updates are as up-to-date as possible. And then, when you look at just how much we've done on the Play side, this is impossible to read, but it's a list of a number of the things that we've done over time with Play to ensure that we're shutting down old vulnerable versions of SDKs and these sorts of things. So now I'll hand it over to Pietro to talk about what Zebra is doing here.
Thank you, Andy. So we have seen what is the part of Google as the company behind the operating system and the whole Android ecosystem. We, as Zebra, as part of this ecosystem, we have our role to be sure that all the good job that Google is doing on the operating system, updating explosive vulnerabilities, is brought to the device, is pushed to the device. So we are really working with these three paradigms for us, for Android. Starting from a very solid foundation. So we have seen all the good work that Google has done on the operating system since the beginning on the architecture, and then every new version of Android is updating this architecture to improve the security, the baseline security, the core security of this operating system. For us, there is a focus to have a EMM taking care of the devices to be able to push update to the device for the security updates and to work with in a kiosk mode on the device. In this way, if you can be sure that no potential harmful applications are installed on the device, is a very good security point. You are already taking out a lot of the risk that are discovered over time. But the key point for us that probably set us apart to all the rest of the Android ecosystem is that we work with a very long life cycle on our devices. So when we think about devices like the TC75X, is a device that we introduced this year. we are going to sell this device for 5 years and support the device for 5 additional years. So we are talking about the life cycle of these devices that are 5, 7, 10 years for our customers. And we need to provide the guarantee to have security updates and security on these devices for the whole life cycle of these devices. So this is why we introduced this year this Lifeguard for Android. That is really our answer to this question. How can I have my life cycle out of my device that I bought this year? I want to be able to use it till 2023, 2024, but always having a secure device. So, and we see this coming from a different question, different point. We arrive at the end at this strategy. So customers want to have a modern operating system. This means to have something that is user-friendly. It's user already know how to use, and this point with Android, we really tick this box very well. And to have a successful enterprise operating system, modern operating system for the enterprise, it needs to be a consumer operating system with a large success in the consumer market, because the scale of the consumer market is so big that it's the only driving force for all the innovation. So if we think about all the different rugged device manufacturers, in a year, Zebra, Honeywell, Datalogic, all of us, we are selling less than 5 million devices in 1 year, all of us combined. That is less of what probably Apple will sell in the first weekend of the launch of the iPhone, or Samsung with the new flagship device. So we need to be sure to be attached to this market, but not losing the focus on the security, because a successful consumer operating system is going to be attacked by virus and malware, simply because if I'm spending time building a virus and a malware to gain some money, to gain some value out of these devices, I want to target most of the devices at this moment. And as Andy was saying before, Android nowadays is the most used operating system in the world. So our answers to this question is really to be able to provide 30 days security updates for our devices, or for the longer life cycle or the older devices, we are talking about providing security update at least every quarter. The next question is really, okay, I now have the capability to be secure on my device, but I still want to cover my total cost of ownership. So the idea that I buy a device with an investment and I can use this device as long as possible. So we have seen over the year that we have customers that they want to use our devices for 5 years or more, and we have in some cases customers still using 10-year-old devices. But the operating system, the consumer operating system, is moving very fast. How can I put this together? So I have a new version of Android every year. So what we are doing on our devices is that all the new devices came with Lifeguard, and Lifeguard is available with security patches at least up to 2 years after the end of sale. Means that TC75X is on the market since January this year. We are going to sell this device till the 2022, and we are going to provide security updates at least till 2024. So this included with all the maintenance packages that we have, with all the Zebra One Care solution that we have. This provides something that is not available anywhere else in the market. So having security updates on a device to guarantee the life cycle of these devices. The problem is that we are even releasing new OS version on these devices. So, and usually when you work on a consumer device, you get for sometimes security updates, but when there is a new version of the operating system, the security updates are released for the new version of the operating system. So, but probably IT organization, enterprise customers want to have sometimes when there is a new version of the operating system, moving from Marshmallow to Nougat, from Nougat to Oreo. They want to have sometimes to validate all the solution on the new operating system, the software, the infrastructure, the network, and so on. So you cannot really expect that they move in less than 30 days to keep always the security updates available on the device. So what we are doing in this case, we are providing this OS transition period. 12 months where we are going to supply security updates for the previous version of for the previous operating system and for the new operating system. To give you an example, end of this year, we are going to release Nougat for the TC75X. We are going to provide security updates till end of 2018 for Marshmallow on this device and on Nougat on this device. And this is really to guarantee the life cycle. It's really, I think, we built a lot of differentiators on Android on our devices with MX, this mobility extension. But all the work we are doing to bring forward all the Android ecosystem for the enterprise with Google, bringing some of the features that were unique to Zebra device in the larger Android ecosystem. For us, for the future, the biggest difference that we have, the biggest advantage that we have against our competitors is really the capability to guarantee this kind of life cycle, this longer life cycle. So for the hardware, we're always done devices with very long life cycle, 3 years of selling the device plus 3 years of maintaining the device, or 4+4, 5+4, and so on. This is for the hardware. Compared to the typical consumer device, the best-in-class are available on the market for 2 or 2.5 years. For the security updates, so first of all, not all the vendors are capable to provide 30 days security updates for the device. There is now, since Marshmallow, there is the capability to see what is the security update level on your device. It's usually you get the date of the release of the security updates. And we see that we are best in class in this case for how long we provide security updates. For 3+3 years devices, we provide 5 years of security updates. For the 5+5, like the TC75X, we provide 84 months of security update, 7 years of security updates. We have this OS transition period that is not available anywhere else on the market. And for customers that want to have an extended period of transition, or they want to have a longer life cycle, they want to have security updates even after the end of the coverage included in OneCare with Lifeguard, we are able to provide a paid service where we are able to provide security updates for a longer life cycle. We have customers that are asking us to have support on some of our devices, security updates, till 2024, 2026, and we are able to go back to them because, as Mark was saying, we have done a huge investment in resources in engineering now that we are moving to Android, and a lot of the resources that we have in-house is really to work on the security patches for our devices. And just to state again how much is important security for our market, this is a report that has been released by the US Department of Homeland Security last month in August, and they have is a study on mobile device security, and the key point that they are pushing is that really it's key to have security updates for the device. It's impossible to think that a device is released with an operating system that is not to be vulnerable in the coming years for some reason, for some new discovery by security researcher and so on. So it's important, it's really key to be able to provide security updates, and otherwise there is no security at all. So once the device doesn't receive any more security updates, it's like using Windows XP without Windows Update. It's not really a good idea. So these are some of the resources made available by Google and Zebra. Google released a monthly security bulletin with all the vulnerabilities that are covering month by month, with a description and a lot of information. There is a year in review, released again by Google. The latest version is 2016 year in review, where they provide a lot of the information, a lot of data. It's very nice to work with a company like Google because they are very good collecting information, collecting data, and understanding trends out of this data. A lot of the information we have seen in these slides are coming from this security year in review. And if you want to have more information regarding Lifeguard, the detail of what we provide, how we provide the security patches, because it's not something that we push on the device, we make available the security patches, and it's something that the IT organization can validate and then push on the devices. We are working to have an integrated solution with the EMM, but we are not in the, it's not our market is to push the security updates or the OS update to the device. It's always a work where the IT organization is in charge to decide what needs to be installed on the device.